Welcome to the lesson. Of course, product, as you should know, is what you get when you multiply things together. So the product of 4 and 5 is 20. 20 is the product. It's what you have when two things are being multiplied together. The answer is the product, right? And so the product rule in differentiation is a rule about differentiating functions. Two functions. Well, you're differentiating one function, but that one function is made up of two simpler functions being multiplied together. And here's an example. So, for example, if you had y is equal to x squared, and then you had open bracket 3x plus 2 all cubed, then that is one function. X squared is one function, and this is a second function. In fact, that's probably like a function inside a function, but on the whole, that's two functions. X squared is one function, 3x plus 2 all cubed is another function, and they are being multiplied together, right? And that's why, whoa. Okay, so yes, back, they're being multiplied together. And then another example might be y is equal to x squared multiplied by sine x. Now, I know you don't know how to differentiate sine x. That's okay. The point is you have one function here and you have another function there, and they are being multiplied together. To differentiate that whole thing, you would need to use the product rule, because you have two functions being multiplied together, and so to differentiate it, you need to use the product rule. And so anyway, what is the product rule? Well, the product rule says if you have y is equal to uv, where u is a function and v is a function, right? So x squared, you could say that's u, and sine x, you could say that's v. Or you could have that is u, and this is v. You get the idea. You have two functions being multiplied together. All it's saying is you have two functions being multiplied together, where u and v are functions of x. Then how do you what's the answer? How do you differentiate it? Well, y prime or y dash, as I like to say, is equal to u dash v plus v dash u. I know a dash is like that. I don't know why. When I was in high school, I learned it. I just memorized it like this, u dash v, and I call this a dash. I know it's not a dash. Just bear with me. That's how I learned it. You can learn it like that as well. Or you can learn it u prime v plus v prime u. It's up to you. Anyway, the way I memorize it is u dash v plus v dash u. And that's it. So that's product rule. If y is equal to u v, then y dash is equal to u dash v plus v dash u. And you're done. So what that means is you would differentiate u and multiply it by v. Then you add the derivative of v prime and multiply by u. Okay? Now, let's have a look at an example. I think it'll be a lot clearer. Now, of course, u of x and v of x, or u and v over here, as the case may be, u and v are functions in x. Okay, so you have an x there and x. So you can't have x squared and over here it's suddenly, 3t or something like that. Now, they're going to both be functions in x. That's just a technicality. Anyway, let's say you had to differentiate that. Well, how should you set out your working out? What you should do is you have this, you say, let u equal to 4x minus 5, then u prime or u dash is equal to 4. And then you say let v equal to, and then now we're gonna call that v, right? So v is equal to 3x squared minus 5, then v prime or v dash is equal to 6x. Just start off like that. Okay, that's all I've done is I've said let u equal to 4x minus 5, call this u, okay, and the way we write that in mathematics is say we let u equal 4x minus 5. And I differentiated it. Then u dash, u prime is 4. And then we said we're going to call that v. How do you say that in maths? We say let v equal to 3x squared minus 5. Okay, and then now I say then, by the product rule, y prime is equal to u dash v plus v dash u. and I'm just going to sub stuff in, right? So what's u dash? What's u prime here? U prime is 4. So y prime is equal to u prime is 4. So I write 4 here. What's v? Just use brackets every single time you sub something in. Use brackets. I've been saying this for a few years now to you guys. Class of 21 anyway. But future students and other students, anytime you sub in, always use brackets. Okay. And then close bracket, and you have a plus here, right? So plus, now I'm going to do v prime, v dash. V dash is 6x, all right, 6x here. And then use brackets. What's u? U is 4x minus 5, so let's write 4x minus 5. And look, you could expand that if you wanted to, but like that's the product rule. In essence, that's it. Expand, simplify, and so on and so forth. That's basic algebra, and I'm sure I've done it in the slide here. Yeah, expand, simplify, and you end up getting that cool story. But hopefully you saw my thought process and the way I've laid it out. It's very important that you lay it out the same way. You should not be doing it in your mind, even in the HSC. So the chain rule, perhaps, you can do it in your mind in year 12, in the HSC, perhaps, if you practice it heaps, and you can do it without making a single mistake. Even if you did like 50 questions, you wouldn't make a single mistake, then you can do it in your mind. But for the time being, show all the working out. Okay, so let's have a look at another question. So check your understanding, pause the video, and try and give it a go. Make sure you do all the working out properly, and then come back, and let's see, we'll go through it. So hopefully you've given it a go. Remember, maths is something you learn by doing, not by watching other people do. You've got to be giving it a go yourself. Struggle, try, make mistakes. It's fine. That's how we learn, okay? Anyway, so we let x squared plus 1 all to the power of 4, we let that equal to v. We let x cubed equal to u. So we're going to call this u, we're going to call this v. Notice I'm calling the whole thing v, right, including the power of 4. And to differentiate v, we will need to use the chain rule, which we have just finished learning. So as you can start to see, we're starting to mix multiple rules in, right? Power rule, chain rule is being mixed together when you apply the product rule. So you just have to practice. That's the only way to get better, only way to be number one, in the words of Fatality. I'm sure I've shown you the video for my current students and any future students. Anyway, let's keep going. So we've done that. The next thing we do right then, u prime equal to, okay, since I've written over here, I'll just write u prime equals to 3x squared, and you write v prime over there, and so on. Okay, so I'm going to use a chain rule here. Fair enough. So let's do it slowly, just in case you're not 100% with the chain rule yet. So how would you differentiate that? The 4 comes down. Okay, so we are differentiating v. So v dash is equal to the 4 comes down. We leave the inside alone. Decrease the power by 1, so 3. And then I will multiply by the derivative of the inside. The derivative of the inside, which happens to be 2x. So multiplied by 2x. And that's 4 times 2 is 8x, x squared plus 1 all cubed. So I put the 2x to the multiplied by the 4 to give me 8x, and that's v prime. And of course, u prime will be 3x squared. And now I'm set to use my product rule, u dash v plus v dash u. And by the way, I should probably point out, I'm sorry I'm being a little messy, which is why I remembered actually. I see a lot of students, they write this very sloppily, and then they end up mistaking the u's and the v's. So go out of your way to make sure the u's look like that, and the v's look like that. Because it's very, very easy to mistake the u and the v. Anyway, so you have that. By the product rule, you have that, and then you substitute in. U dash is 3x squared. V, leaving v alone completely, is that. And then you have v dash is 8x. V dash was 8x, sorry, was that whole thing. Sorry about that. And then multiplied by u, and u is x cubed. So write x cubed here. Expand, simplify, all that stuff. Not always necessary, especially when it's cubed, it's the power 4. No one's gonna expect you to expand that. You don't have to worry about it. If it's squared, maybe you can think about expanding it. So, for example, if that was 3x squared x plus 5, I'm completely making this up. If that was a squared, maybe you'd think about expanding it. But even then, I personally would not expect you to expand it. That is fine. That is completely fine. It's not a test of algebra. It's a test of whether you know the product rule or not, I suppose. And, it depends on the situation. Anyway, I don't want to complicate things, so let's just keep moving on. Here's another question. As always, let's check your understanding question. So pause the video, give it a go. You learn by doing, by struggling, by taking your time. That's how you learn. Learning takes place in your mind. It doesn't take place anywhere else except your mind. And the only way it's going to take place in your mind is if you actually do the question. So do the question, struggle a bit, sweat a little bit, and that's how you learn. So pause the video, go away, give it a go, and then come back and we'll discuss it. Okay, I'm assuming you've given it a go. So let's see. We let u equal to that. We let v equal to that. U prime by the chain rule. The 3 comes down. 3 comes down. We leave the inside alone. Decrease the power by 1. Multiply it by the derivative of the inside. And I've taken the liberty of multiplying by the derivative first. But hopefully you can see that. And you should have ended up with this. Pause the video if you got it wrong. That's okay. Just make sure you understand it. Give the question another go. If you got it wrong, do it again. Doesn't matter. Do it 3 times, 4 times. Who cares? The point is to learn it. Be familiar with it. Practice it heaps. U prime, same thing. We're going to use the chain rule. And by the product rule, y prime is equal to u prime v plus v prime u, or u dash v plus v dash u. And do the appropriate substitutions. Simplify and factorize if needed. I guess over here you'll be factorizing because you have x squared plus 1 all squared there. You have x squared plus 1 cubed, so you can take squares out. Or not, I guess I didn't actually do it. If you want to, I guess you could factorize. Yeah, good practice, I suppose. But you can leave it alone as well. Okay, another example. Differentiate the function below, writing the result in fully factored form. So it is asking you now, the question is asking you to write the result in fully factored form. And then state for what values of x the derivative is 0. And that's why they're asking you to factorize it. Because to use the null factor theorem, you need to have it factored. And I guess when we do the question, you'll see why. So you have that. We'll let u, v, u prime, v prime. Hopefully you can, that's not the focus of this question, so I'm not going to go out of my way to show you how I've done that, the u prime and all that stuff. Just accept it. It's there. I've done it for you. Let's move on with the question. U prime v, u dash v plus v dash u. And move forward. As before, we multiply the u with the v prime, and the u prime with the v. Or just make the appropriate substitutions. And u prime. Look, I'm just gonna move forward. Like I said, the video is getting a bit long. I don't want to waste your time. We've done this a couple of times. You can go back and watch. The focus is not on this. The focus over here is we have to factorize, then find what values of x the derivative will be 0. So let's just skip forward. Okay, and actually. So up to here, how do we factorize this? Well, what's common? What's common? Let's start by factorizing out this. 3x plus 2, all squared. And so how many instances of 3x plus 2 can I take from here? 2 instances, because it's squared. And over here it's cubed, but we can only take squared out. And so we write 3x plus 2, all squared. Okay, what do we have left over? We have a 2x. 3x plus 2 plus 9. I took that complete thing out, and we have 9x squared. Can I take out anything else? I think we can. So let's just keep going. So you have 3x plus 2 all squared. And over here with 2x multiplied by 3, 2 times 3 is 6, x squared. 2 times 2 is 4, so 4x plus 4x plus 9x squared. 6x squared plus 9x squared is 15x squared. So I hope you will forgive me for being a bit messy, but I'm just going to do it like this. 6 plus 9 is 15. Can I take out anything? I believe I can take out an x here. I could have taken out x from in the previous episode, my bad. Anyway, I can take out an x. 4 and the 15 have no common factors. So just let's pull out an x. So we'll have x, then we'll have 3x plus 2 all squared. And then what do we have left over? We have 15x plus 4. And that is fully simplified. Then state for what values of x the derivative is 0. Well, I've differentiated this, so this is y prime, this is y dash, this is the derivative. What values will the derivative be 0? Well, let's just solve that. If that was equal to 0, where would it equal to 0? By the null factor theorem, x equal to 0, that's one solution. 3x plus 2 has to equal to 0, so 3x. And I'm being very messy here. 3x equals to negative 2. So x equals to negative 2 on 3. That's the second solution. And we have a final solution. 15x plus 4 equals to 0. 15x equals to negative 4. X equals to negative 4 over 15. And that's our third solution. I hope you can rewind that. I just use the null factor theorem here. If there's anything you don't understand, you can always ask me on Slack. The factorizing bit, yeah, you just have to be really good at factorizing. We'll do another example in a second, see how you do. Just double checking that I didn't make a mistake. Yes, I believe that's what I got as well. So let's move on. Check your understanding. Find the x coordinate of the point on the curve, and that's the function where the gradient is 0. For the gradient to be 0, the derivative has to be 0. So it's exactly the same as what I've just done. Pause the video and give it a go, and then come back and see the answer here. Okay, welcome back. That's probably a very tougher question. Hope you give it a go. If not, look at the solution, then give it a go. You should still give it a go, even after you've seen the solution. Okay, so u prime, v prime, make the substitution, and you are going to have to factorize that perhaps. Okay, so because we need to solve for y prime equals to 0, a good idea when you have an answer like this and you have a fraction is to unify the fraction. Have one fraction only. So unify them. So because you have a denominator here, you can multiply the top and bottom over here by that in order to unify the fraction. And that's what has been done. You can have a look at it if you wish. Let's just move on to expanding and getting on with the actual question. So you have 4x squared plus x squared. And you have that. And the main part of the question that you might have struggled with is, how do you know where the gradient is 0? Well, the tip is, if the bottom, anywhere the bottom is 0, there will be an asymptote. And anywhere the top is 0, that's where the gradient is going to be 0. You might have to use a null factor theorem here. So obviously we're going to need to factorize this. We need to factorize that. And that has been done. So again, we are in almost at the end of year 11. We can't really assume that you don't know how to factorize. So hopefully you know how to factorize that. If not, you need to put some serious effort in, because this is assumed knowledge by now. Anyway, you factorize. Now by the null factor theorem, where is the numerator equal to 0? X equal to negative 1. And x is equal to 1 over 5. And so x plus 1, x equal to -1, or x equal to 1 over 5. That's the x coordinates of the points where the curve will be 0. As always, you can ask me for help on Slack as needed. And that's the homework. Good luck and have fun.